Okay guys, so this is oxidation of alcohols. Also, if you missed this lesson this week because of snow, then definitely do this. So, what I'd advise you do is get some A3 paper, A4 will be big enough, get some A3 paper and do it kind of long ways, so kind of like a normal, the way you'd have it. And what we're going to do is build up a really cool revision tool using what we're going to do on the board here. So every time I'd like you to write something down on that A3 piece of paper, I'll let you know what it is to add on. Okay? So, before we can talk about anything else with the oxidation of alcohols, we need to talk about the classification of alcohols. Because there ain't just one type, there's 3 different types. And depending on the classification you have, will make a massive difference to what happens when you oxidize them. So the very first thing you do when you see an alcohol from now on is you should think, what classification is it? So, how do we classify alcohols? This is a bit of a long sentence here, so I'm going to say it slowly. In order to figure out the classification of the alcohol, I'm going to look at this one here. We look at the OH, we look at the carbon attached to that OH, and we look at how many non-hydrogens, usually carbons, are attached to that carbon. So, here's my OH, here's the carbon attached to it. I have 1 carbon attached to that carbon, so this is a primary alcohol. Let's go for another one. Here's an OH, here is the carbon attached to the OH. I have 2 carbons attached to that carbon. This is a secondary alcohol. Okay. On the back of your sheet, can you copy down those 2 so you've got some examples? You can do a little subtitle, classification of alcohols. Can you then pause the video and can you copy these 4 down and can you have a go at classifying them? So if you could pause it now and unpause, here's what we should have got. So here's my OH, here's the carbon attached to the OH. It has 1 carbon attached to it. You might say, well, yeah, but there's another carbon there. But this carbon isn't attached to that carbon. So this is a primary again. Here's my OH, here's the carbon attached to it, 2 carbons, so that is secondary. This one, we've got 2 alcohols, so we're going to have 2 classifications. They could be the same, they could be different. Let's have a look. Here's the OH, carbon attached to it, 1 carbon, primary. OH, carbon attached to it, 2 carbons, so secondary, or 2 non-hydrogens, secondary. And then finally, here's the OH, carbon attached to it, 3 carbons, so that would be a tertiary. And that's like your options, primary, secondary, or tertiary. Okay, so that's how we classify the alcohols. What do we do when we oxidize them? Okay. So, on the same side as what you did the classification, we're going to add just one more thing, and that is our oxidizing mixture. Okay, this is what we use to oxidize the alcohols. And what we use is potassium, so K2, 2 potassiums, dichromate, Cr2O7. And we need to acidify that, and we use sulfuric acid to acidify it. This is actually acting as a catalyst. This is not, but we still need to add it as well. This is what helps cause the oxidation. So when you add those 2 together, you have your oxidizing mixture. And it's worth pointing out, the only reason we add the sulfuric acid is because it's an acid, so it releases H+. The only reason we add the potassium dichromate is because we want the dichromate ions. Okay, you could say, well, yeah, so why don't you just add dichromate then? You can't buy a bag of dichromate. You have to buy it in its salt form. So you buy potassium dichromate, and as a salt, that will dissociate in solution to release your dichromate ions. Same with the acid and H+. So if you're asked, what do you add to get the oxidizing mixture? You'd say those 2. But often in exam, you might see them write this down. That represents the oxidizing mixture also. Okay, can you get that down on your sheet as well? Pause the video, get that down, and then unpause it. Okay. So what can we do with this oxidizing mixture? So what we can do is we can take a primary alcohol and we can oxidize it. Now, we would put the H2SO4 K2Cr2O7 above the arrow. Usually this is reserved for catalysts. What we're kind of going to do here is cheat a little bit. This acidified dichromate, what it does is it acts to release an oxygen. So it's not quite as simple as that. It doesn't just release an oxygen, but we're going to simplify it quite a lot and just say it's releasing an oxygen, but it's not actually releasing an oxygen, so we're going to put that in square brackets. What this represents is we have oxidation. We have oxidized this primary alcohol. So, as I said earlier, one of the things we need to kind of think about is what classification of alcohol we have. The second thing we've really got to check in the question to see what's going on is what equipment and conditions are we using? Because there's two different types of conditions and equipment, and depending on which one you use will depend on the answer. We could use reflux, yeah, like that. If you're not sure about reflux and distillation, stop the video now and do a once over of that, by the way. We could also do distillation. Okay, so that's our kind of two options, reflux and distillation. I'm going to start first of all by distilling this. So I'm just going to get rid of that for now. So, distill. And what happens when you distill the alcohol is we get what's called the primary alcohol, is you get what's called partial oxidation. So if we imagine my red pen is the oxidizing mixture, the acidified dichromate, and my black pen is the primary alcohol, look what happens when we distill it. They're both in here, they're going to react. My primary alcohol will change into something, it'll be oxidized once. Once it's oxidized though, it will evaporate and then condense into a different beaker. Now, these have now been physically separated. So they can't react a second time, because look, they're not touching each other. Yeah, if I've got one chemical in this room and one chemical in Norway, they're not going to react, are they? Because they can't touch each other, they can't collide. These can't collide anymore because they're in different beakers. They have been, what we say, physically separated due to their boiling points, or relative boiling points. So, with distillation, we're going to get oxidized once, and here's what happens. This O, which isn't really there, we're kind of pretending it is, and that's fine, just go with it. This O pulls off a H from the oxygen there, and a H from the carbon attached to the oxygen. So I have an O, I have two H's, well that's going to make H2O. What's that going to leave me with? Well, this. Yeah, and I'm just going to put this H on. Was a H, it's still a H. So oxygen needs to make 2 bonds, carbon needs to make 4, so they double bond up, and what have we got? We have made an aldehyde, plus water. Yeah, so a primary alcohol, if you oxidize it under distillation, you get an aldehyde and water. What we could do though, if we really wanted to, I could take this aldehyde, remember, which evaporated and condensed, and I could, if I wanted, add it back in. So if I did do that, my aldehyde would be oxidized a second time, and this time, I'm simplifying a little bit here, quite a bit here, but the oxygen sticks itself between the C and the H. So that's going to give us this. So have a little think about what functional group that is. Yeah. This is going to be a carboxylic acid. So if you take an aldehyde and you oxidize it, you will get a carboxylic acid. Really important point here, because everybody goes wrong on this. When we oxidize the primary alcohol, the oxygen pulled off two H's to make water. When you oxidize an aldehyde, the oxygen sticks itself in. It's not pulling off any H's, so you'll notice there's no water released. Yeah? Okay. So, that's what we do with distillation. If you distill it, you'll just get one oxidation. Technically, you could add it back in to do it a second time to go all the way to a carboxylic acid. Have a look what happens with reflux though. If I was to reflux this, my primary alcohol would oxidize once into an aldehyde. My aldehyde would evaporate and condense back down into the reaction mixture. So it's going to oxidize twice. Basically, with distillation you get one oxidation, so partial. With reflux you get two oxidations, complete oxidation. So, if I take my primary alcohol again, this time I'm going to reflux it. We're going to get two oxidations, and my primary alcohol will oxidize once to give an aldehyde and water, and then straight away my aldehyde is going to oxidize again to give a carboxylic acid. So overall, we're going to end up with a carboxylic acid plus one water from this first step. Because there's no water in the second step, is there? In this second oxidation, it does not produce a water. Everybody puts a 2 there. Be really careful with that. So what have we got then? A primary alcohol plus 2 oxidations, so complete oxidation will give us a carboxylic acid and 1 H2O. If you can stop the video in 2 seconds, turn over to the fresh side of your A3 paper. Can you get that down? And obviously make sure you understand it when you get it down. If there's anything about that you didn't understand from the video, just make a little question at the side, make a note, and bring it to me like next lunchtime, and we can go through it, or at the start of next lesson. Wherever. Okay, so that's primary alcohols. Okay, secondary alcohols. So, secondary alcohols can only be oxidized once. So it doesn't really matter whether we do reflux or distillation, because you're just going to get one oxidation anyway. So whichever one you want to do, you're going to get oxidation. And the same thing happens as with a primary. The oxygen steals a H from the OH and a H from the carbon attached to the OH. So again, just like with primary, we're going to get water, and that's going to leave us with this. And then just like with a primary, the O and the C, they're going to double bond, and so now we're going to get a ketone. Okay? And so our overall equation is secondary alcohol plus, well, oxidize it, and you get ketone and H2O. Very finally, we have a tertiary alcohol, so where the OH is attached to a carbon bonded to 3 other carbons, or non-hydrogens. So okay, let's try and oxidize this. Let's see what happens. So remember, with both a primary and a secondary, for the first oxidation, the O took off a H from the OH and a H from the carbon attached to the OH. Let's try and do that again. So my O is going to take off a H from the OH and a H. Can't do it. There is no H. You cannot oxidize a tertiary alcohol. So that's oxidation of alcohol. The colour of your oxidizing mixture, the acidified potassium dichromate, is orange. And there's loads of videos on YouTube of that. You can type it in and see the colour change. If it does do its job, and if it oxidizes something, it will change to a green colour. Occasionally it looks slightly bluish, but the official colour change is orange to green. So if you had an alcohol and you, I don't know, refluxed it with your oxidizing mixture and it stayed orange, what would that tell you about the alcohol? Well, it must be a tertiary alcohol, because that's the only one which doesn't oxidize. So that's a nice little trick to figure out you've got a tertiary. Okay guys, so if you can copy that down underneath the primary alcohol bit, you'll then have your reaction mixture and classification on one side, and then you'll have your actual equations on the other. And it's the word equations you need to memorize, but I would still have these symbol equations so you can picture it in your head, because you need to be able to see what the functional groups look like. But it's really the bit in red which you really need to boot camp. Okay, and of course we've got our observation there as well, unless it's tertiary. Cool.